right? So the fourth application is called optimization. So optimization means you want to make things in the best scenario, right? What's the best scenario to do something, right? So you've done something like this in grade 11 as well without using calculus. And then we can try to compare how calculus can help us get the same result faster, right? So because in grade 11 you learn about parabola, and parabola we learn how to find the vertex, right? So vertex could represent the highest or the lowest point. So highest and lowest, those are called optimization, right? The best, right, or the worst, right, or the longest, right? Anything that's the extreme, right? And derivative can help us find the extrema, right, which connect to our graphing section. Okay, so let's look at the introduction here. Here we'll apply the techniques of finding extreme values to solve many problems in which a function is to be maximized or minimized, right? So just like finding extrema. Such problem usually involve optimizing the time, right? So you want to make the time as fast as possible, right? For example, travel from one place to the other, or distance, right? Find the shortest distance. Um, Maximize the volume, right? If you have certain amount of material, you want to build a can, right? And then minimize or maximize the area of a parking lot, right? Minimize the cost during a production. Okay, so these are some of the examples you can apply calculus to. So let's start with the simple questions first. Okay, these two you've seen it in grade 11. So we just use these two as a demo to show you the steps if we want to use calculus to find the answer. Okay, so here we have two numbers that have a difference of 8. Their product is minimum. So if you remember, right, from grade 11, the thing that you want to minimize is always the y. Okay, so this is the product we want to make a minimum. Okay, and we want to find the two numbers that can make that happen. So the first step, right, is always to write out this let statement. Okay, so we have two numbers. We can say the first number is the x, right? Second number, we cannot say it's the y because we want to save the y for the thing you want to minimize, right? So we want to find a relationship between first and second. So if we know the first, how do we get a second number? Jeffy?
You know that they have a difference of 8,
Yeah.
so it would just be x minus 8.
Can we also do x plus 8?
Yeah, because it would still have a difference between the two numbers of 8.
Okay, very good, right? As long as they are 8 apart, right? So let's say we just pick x minus 8. Right? So there you go. That's the two numbers that we want to find, right? And then the thing we want to minimize is the product. So right product will be the y. Okay, remember you need to identify what you want to make it optimized, right? Now step 2 is to write out a function. Okay, write a function that connects all the items together. So this one is pretty straightforward. Product, right? Product is the y, is the two numbers multiplied together. So x times x minus 8. So this is our function, right? In grade 11, we will start by drawing the functions, right? From here, this is called a quadratic function. And then by looking at this function, we know the x-intercepts. Where are the x-intercepts for this quadratic function? Leon?
8.
And
not quite sure. Oh, 0. 8 and 0.
yeah, very good, right? Because you have an x outside, right? So you have 8. So let's say somewhere here, 8, and then 0 at here, right? And this parabola should open which way, Joan?
Should open up.
Yeah, opens upwards, right? So it looks something like that. And what we are looking for is looking for the x values, right? To make a minimum, right? Because the y is the product, right? We want to find the lowest product. And by looking at the graph, we could already see that x has to be 4, right? And then in grade 11, we learned to find the vertex, right? And then by completing the square, right? You have to do a lot of stuff, right? To get the 4. This one is pretty easy, right? But let's see how the derivative can help us now. So let's simplify this function. X squared minus 8x, okay? So that's our function. Now step 3, once you got a function, right? You want to find the minimum place. At the minimum place, the derivative is 0, right? So we will find the critical values, just like what you learn in graphing, right? All the important places, we need to find it. So critical values. Okay, to find critical values, you either make the prime equal to 0 or undefined, right? So we will find the derivative now. So y prime equals, this one is pretty easy, right? 2x minus 8. And then we make this slope equal to 0, right? This one is no way to become undefined, right? So x equals to 4, which matches our prediction here, right? So you see, without completing the square, we can find the location of the minimum very fast, right? But sometimes if the graph goes more curved, right, there could be more than one maximum or minimum places. So you need to check, right? Because when you prime equal to 0, it could happen at a maximum, right? It could happen at a minimum. You want to make sure you get the correct one, right? So last step, you need to double check, right? By testing the number line. Just to make sure that the critical value you get is a minimum, right? So we do the same thing as graphing, right? We place the critical values, right? And then the bottom part is the f. So pick a number and then plug it into the prime. Okay, make sure you plug it into the prime. So for example, I'm plugging 3 into the prime. Okay, if I plug in 3 into the prime, what would you get, Emily?
You would get a number that is smaller than 0.
That is what?
You would get like -2.
Negative number, right? Smaller than 0.
Yeah.
Okay, so negative, and then the other side will give you a positive if you try to plug in 5, right? So that tells us it's decreasing on the left side, increasing on the right side. So that confirms it's a minimum place at x equal to 4. Okay, so it just takes 4 steps here. And then we can say the first number, right? We have found x equal 4 is the one of the number, right? You look at your last statement now, right? So you can say the numbers are 4, and to get a second number, the last statement tell us to -8, right? So we'll give you -4. So that will be our final answer. Okay, so of course in calculus, we are not doing question like this simple, right? But the steps are all the same. Okay, just like related rates. I give you 5 steps, but question can varies, right? So I just use this example to show how the steps will work, okay? So the function you will be building will be the more complicated, right? More difficult to prime. So I think the hardest step is to try to get the function, okay? Step 2. Okay, afterwards is priming. You apply all your rules, right? Product rule, quotient rule, chain rule, those stuff. Okay, and then critical value number line is what we learned last week. All right, so let's get to it, right? We'll look at harder questions. Okay, let's look at question on the next page. So in this section, I divided into different types, right? First one is like finding numbers. Okay, Jesse has a question, I think. Okay, so Jesse asked, how is it 4 and negative 4? Okay, can someone explain that? Joan, why is it 4 and negative 4?
Because in the let statement, we said the first number is x and we found x was 4. So then for the second number, since the two numbers have a difference of 8, we just minus 8 from the 4.
Okay, thank you, Joan. Does that explain, Jesse? Does that answer your question? Okay, yes, he said yes. Okay, and he said thanks. Okay, so Jesse had the mic is broken. Maybe try to fix it over the week. Okay. All right, so let's go to look at what types are there, right? We have 2D and 3D geometry, right? 2D is like making a square or circles. 3D is like a sphere, okay, or anything cylinder, right? And then type 3 is called the coordinate geometry. So we will have X and Y axis. That's called coordinate geometry. And then we have others, okay? I hopefully we can finish all of them and then do our last application as well, okay? So let's look at 38, okay? A 2D, I think 38 is a 3D. Let me see. Yeah, this, okay, then we'll do 37 first, okay? So I'll let you read this question. This question also appeared in grade 11 too, but then we're gonna do it in a calculus way, all right? So I'll let you try to do the 4 steps, okay? How about once you get the function, okay? Let's not go too far ahead. Once you get the function, you can raise your hand, all right? So farmer has 2,400 of fencing and wants to fence off a rectangular field that borders a straight river. He needs no fence along the river. What are the dimensions of the field that has the largest area? Right? So the thing you want to maximize is area. Make sure you pick that up. Draw a picture, okay, on the side. River with a shark inside. And then you put fence. Rectangular field, right? Those are grass.
Jason, do you want us to stop at the function or do you want us to continue?
If you are sure your function is right, then you can continue. Yeah,
Okay.
you can move ahead. But please raise your hand, okay? So I know everybody has finished step 2. Anyone has question about last statement? Please raise your hand if you got the function and the last statement. This one is similar to the previous page, right? Instead of finding two numbers, we are finding the dimensions, right? So it's kind of like finding two numbers. Okay, let's check the last statement first. Emily, what's your last statement?
I have a half W and then in brackets 2,400 minus W. I don't know if it's right. It's probably wrong.
No,
but-
sorry, I didn't catch what you mean by that. You said half W?
Yeah, and then in brackets 2,400 minus W.
Oh, you mean the function?
Oh, sorry, let statement. Oh,
Yeah,
sorry. I have W as
Okay.
the width.
Okay, width is with W, yeah, and then?
And then the length is in brackets 2,400 minus W divided by 2.
Oh, okay, okay, and then?
And
Well,
then the
the thing you want
function
to,
is just the two of them multiplied together.
so that's called the
function.
area,
Yeah, the area.
right? We need another one for the thing you want to optimize. So we can call it A then. Okay,
Mhm.
anyone has question about how she got the last statement? So I get the, depending on how you choose to be the width, okay, your setup might be different, right? So I think for her, the width is on the longer side here, right? And then 2,400, take away the length, the width, and cut in half to split it into each one, right? 2,400 minus W over 2. But if you choose the other way, right? If you choose this side to be width, then the one at the bottom, it will just be 2,400 minus 2W. Then this one, it doesn't have any fraction, okay? But either way, at the end, your dimension will be the same, okay? It doesn't matter. All right, so Joan, what's your function look like? Are you using the same let?
I used the other one, the 2,400 minus 2W one. I used that one.
Okay.
Yeah. So
Okay.
my function,
Yeah.
sorry.
So that's okay. Let me see. Is there anyone using the first way, Emily's way? Carrie, did you use the same as Emily?
I'm using the second one.
Second one, huh? Okay, that's all right. Oh, you did that? Okay, Jesse did that? Okay, but it will be difficult for you to type out the function. It's okay. All right, so let's just carry out then, okay? Anyone else doing this way? With the fraction. Okay, most of people did the other way. Okay, that's fine. All right, so anyway, I'll continue, right? So area will be, and you guys can move on, right? See if at the end you get the same answer as this way, right? So that way you can confirm, right? It doesn't matter which way you do. So we will multiply it out. Right, half, I can move it to the front, right, if I want. Okay, and then simplify this. We'll give you half. Okay, if we multiply it, it will give you 12 100 W minus half W squared. Okay, so after that, you carry on to step 3, get the critical values. All right, if you finish all the way to the end, please raise your hand. Okay, if you got the dimensions. So here, if I prime, it will give you 1200 minus W. Right? There's no need to complete a square anymore, right? Make sure you double check. But usually if you have just one answer, right, most of the time that answer will be the answer you want, okay? But then as usually to be 100% sure, right? To be 100% sure, make sure you double check the increasing, decreasing. So here we make it equal to 0. So that one is pretty straightforward. W equal 1200. Okay, can you guys raise your hand if you got the dimensions? So let's test it out. 1200 in the middle, right? That's the critical values. If I plug it in, let's say plugging 1, right? So 1 you plug into the prime, okay? Make sure you plug into the prime one, right? You get positive, and then the other one will be negative. So that confirms that. So what's the dimension then, Leon?
I got for W width, I got 1200.
Mm-hmm.
And then for one length, I got 600.
Okay, 1200 and 600. Is it 600? I got W, yeah, okay, so W is 1200, 1206, yeah. Okay, so make sure you write down the units, right? This one is feet. Okay, so I think this one is fine. Okay, for question 38, okay, we're just gonna go to the step where you got the function, okay? And then we can do something a little bit more difficult, right? So 38, take a look at the questions. Yeah, let me know if you don't know what it's talking about, right? Here we want to make a box. Finding the dimension again. Okay, so here I just want you to do up to step 2, that's all. Okay, is there anyone need me to explain the question more? Or you guys understand what's going on?
I don't really understand it, but
Okay, so here we want to make a box, right? Do origami kind of, right? From a cardboard, right? We want to cut off stuff. So you will start with a cardboard. Cardboard is a 2D. And how big is that cardboard? Leon?
12 by 12 cm.
Yeah, 12 by 12, right? So I'll put 12 and 12. And then it tells you to cut, right, a square of side length x to be removed from each corner, right? So we have 4 corners here, right? And what's the dimension of that corner? Leon?
It's X, right?
Yeah, it will be X by X, right? So it will be here, here, right? It's all by X, and then we cut them off. And then what do we do next?
And then the sides of the box are folded up.
Yeah, okay, because once you cut it off, you can fold it, right? Imagine all the red part are thrown into the garbage can, right? You can fold it along the green line,
Oh, okay, I see now.
right? Once you fold it, it looks like a box. Of course, it won't hold anything. You got to tape the corners, right? Then it becomes a 3-dimensional box. Make sense now, Leon?
Yeah.
Yeah, okay, so try out the less statement. Okay, if you got the function and less statement, please raise your hand.
Wait, Jason,
Yeah, Joan.
do we also know the height of the box? Is it also just is it like a cube?
The height, well, think about the picture here, right? The part that we cut off is the X, correct? Right? So if I fold it, what happened to the side that you cut off?
It'll be smaller, and it'll go taller.
Okay, let's say if the X, the dimension of the square you cut off is like 2 cm,
Mm-hmm.
right? So after you cut it off, right, it will look like, let me draw one more picture underneath. Right, do you see it?
Mm-hmm.
Yeah, okay, so this part will be 2, right?
Yeah.
And how long is this side?
It'll be 12 minus 4.
Yeah, so that's what?
8.
8, okay, so if I folded everything, right, for the green line, right, can you tell me where the 2 and where's the 8 in the box, in the middle picture? Can you show it on the screen?
Oh, you mean oh, I get it. Okay, wait, yes. Let me just get the annotate thing. Wait, in the middle box, right? The actual
Yeah, in the middle box, where should we put the 2 and the 8?
Oh, why is mine so thick? I don't know.
Okay, yeah, I can read it. Yeah, so there you go, right? So that's the height.
Yes, I get it now. I thought it was already a box, so I was confused because I don't know how a box could turn into another box. But this makes
No,
sense.
you start with a cardboard,
Yeah.
right? And then you cut it off and then fold it into a box.
Okay, that makes sense. Thanks, Jason.
Yeah, you're welcome. Oh, thanks for clearing that. Okay, so if we erase the numbers here, that will give us X here. Okay, if you have finished the function, please raise your hand. Jeffy, what's your last statement?
I said let the height equal X.
Okay.
Let the base equal 12 minus 2x bracket squared.
Base, what do you mean base?
Like the base of the box.
The
Like
base of the area?
Yeah, the area.
Oh, area of base
Yeah.
is
12 minus 2x bracket squared.
okay. All right,
And
and
then let y equal volume.
y equal volume. Okay.
Yeah.
All right, that also works. Yep. Okay, or maybe you could just write length and width and then be 12 minus 2x. That also works because we're interested in dimension, right? So when you write the less statement, right, it's better to have dimensions in the less statement. Okay, please raise your hand if you got the function. Nicole, do you have any questions?
I'm still trying to do the function.
Okay, do you have the same less statement?
Yes.
Okay, so how do you get the volume?
You times everything together.
That's it, right? So there's not much to do, okay? So what do you write, Nicole?
Y equals x times the area base thing.
Yeah, okay, and then that's it, okay? So if we want to do step 3, of course, here you can expand, right? But it's not necessary, right? Because step 3, you want to find critical value, you can start by the product rule, right? And then chain rule as well. That's why you learn all the rules. So you don't always have to expand your function, right? What if it's like to the cube, right? It will take forever to expand it. So afterwards, right, then you apply derivative rules. Okay, so let's look at another question now. So the next one, starting next one, we're gonna carry through, okay, to the end. So this one will be a little bit more difficult, okay? Different from what you've seen before. Okay, so here we want to find the largest rectangle, right? Find the area of the largest rectangle that can be inscribed, right? Meaning it can be placed inside in a semicircle of a radius 10 centimeter. Okay, think about what it means and try to draw a picture. And I'll ask you to draw on the screen, okay? Find the area of the largest rectangle that you can place it inside a semicircle. And that semicircle is fixed, okay? Radius is 10 centimeter. Okay, if you got a picture on your page, can you raise your hand? Jesse, how about you?
I fixed it.
Oh, yeah.
There we go.
Congratulations. Okay.
I just kept flicking my thing against the mic. I think it's like something inside the mic. So I just kept flicking it until I guess it lined up or something.
Yeah, because at the very beginning I heard you said one word.
Yeah. It's it showed up and then it cut off. And I kept talking except Zoom kept saying I was muted or something. Except I'm muted and nothing worked either. So I thought it was I just kept smashing my microphone, which I don't think is the best thing to do, but we tried.
Well, it works for today. Well, yeah. Okay, we'll come back. Then how about you show us your picture then, Jesse?
Oh, my picture? Okay. Do you want me to draw it?
Yeah, please draw on the screen. Yeah.
Okay. So I went I drew the semicircle like this. Ooh, sorry, that looks like Pac-Man. And then I thought is like something like this because it has to stay within the semicircle, right?
Yeah. Okay.
Yeah. So
You
that's what
want to
I.
make it as big as possible, right?
Yeah. So that's what I tried to do.
Yeah. Very good.
Wait,
Okay.
I have a question though.
Yeah.
Because like, if the length gets longer,
Yeah.
then the width gets shorter, right?
That's right.
So like, how do I draw it so I know it's the biggest, or do we solve it?
No,
Do we just solve it?
We need to solve it to find out. That's
Oh,
what-
okay.
right. So
Okay.
it has to look like this way, right? Of course, like Jesse said, right? It can be longer. Can you help me erase the picture then?
Yeah.
Thank you. All right.
There we
So
go.
I'm gonna put it on the right side. So semicircle. Right. So for example, if I follow that, right, follow Jesse's drawing, it will look like this, a rectangle there. Of course, I extend it a bit longer, right? I want to make it bigger. So the green one, right? Longer length. But then at the same time, the width will be shorter. So which one looks bigger, right? Not sure. Maybe I can make it taller, right? So I'll use the purple one. Right? Feels like bigger, right? Not sure, right? I make it taller, but then your width will be shorter. So somewhere there in between, there should be a maximum dimension, right? That makes the area as big as possible, okay? Within the semicircle, right? And then radius is fixed. We have 10 centimeters. Okay, so we need to have that statement, right? Doesn't matter what kind of question, the steps are the same. So in the last statement, you better include the thing that you want to optimize, right? And also the thing that you want, the thing that relates to the thing you want to optimize. What I mean by that is, for example, here, we want to optimize the product, and the thing that relates to the product is first and second number, right? So that's how you can choose the last statement. For example, here, I want to optimize area, right? And then it got to do with width and length, right? Optimize the volume. So it got to do with area base and the height, right? So how about here? What's the thing you want to optimize? Leon?
Area?
Yeah, we want to find the area optimize. So what's the thing that related to the area then? Leon?
Length and width.
Yeah, so we got to do the length and width. And it's the length and width of the rectangle. Okay, so let me erase the too many rectangle here. Okay, so too confusing. Let me erase the green one. Oops. And the purple one. Okay. So we need some variables, right? So how do you want to set the variable? Where's to be the x, right? Can be changing, right? Which part do you want to call it x? Any suggestions?
Wait, can X be like I guess the air or like the length.
You want to put it on the pictures for me? Which
Wait,
part?
I have a question though.
Yeah.
Cause like, do we make X like one of the length or the width, or can we make
One
X
of the
like?
dimension.
Oh, okay.
Yeah.
Do you want me to draw it?
Sure. Yeah.
Okay. Or can I? Or is it just the length? I guess the length.
So you mean the top one here?
Yeah, the top one. Yeah.
Okay. Sure. Yeah. If we call that the length, right? Now we need to somehow using the length to find width, right? We need a connection between them, right? Just like our first question. If I know the first number, I need to be able to, using the first number, I can get second number, right? Same thing with the farm, right? This one. using the width, I can get the length. There has to be a connection between those two, right? So look at the picture now. If I know the x, how can we find the width, right? If I know the length is x.
Jason.
Yeah.
Wait. Okay, so my mic works now, so I have a lot of questions. Wait.
Yeah.
But for this one, I was wondering if can we make oh, never mind. I was going to ask if we could make like x the length that's cut off.
Length cut off.
Like wait, can I draw it on the thing?
Yeah, you go ahead. Yeah.
Thank you. Like this part.
Cut off. Yeah. What about it?
Like because you know how the circle, the radius, like it's the same throughout the entire thing, right?
Yes.
So like I was wondering if that's the length that's cut off.
Mm-hmm.
Oh wait, never mind. Sorry, because I was thinking like, it's not the same from the top, right? Because it's 10 centimeters radius, and from the midpoint to the top of the semicircle, it's also 10 centimeters, right?
Yeah, this part is also 10.
Yeah.
Yeah.
But is the area that it's like cut off, like the pink part, it's not the same for the length and the width, right?
Not, you mean not the same as the top part?
Yeah. Is it
It's not the
or
same
is it not?
because remember the red rectangle is changing shape.
Oh,
Right?
okay.
So for example, it could be very narrow, right? The green one.
Yeah.
Yeah. So
Okay.
it's a variable, right? So that's why we should place the variable on the rectangle,
Oh, okay.
right? Because we are looking for the area of the rectangle.
Okay.
Okay.
Okay. Thank you.
Yeah. Okay. So let's get back to. Can you help me erase, please?
Yeah. Sorry.
Okay. So you can choose, right? You can choose, say, length be x or the width be x. Doesn't matter. Okay. But once you chose it, right? So let's say we chose this one to be x. You need to think about, if I know x, is there a way you can use it to find the width, right? If I know the length, can I find the width? So usually with variable, it's difficult to think. So usually I tell people to pretend, think of a number, right? So let's say if I know this one is 12, right? I know the length of a 12. Is there a way somehow you can calculate the other side? Think about this. This is doable, okay? Not too difficult.
Oh, I have a question about it.
Yeah, Leon.
So, can I draw?
Yeah, you draw.
Okay. So I made this side x, right?
Which one? Okay, yeah.
And then because the radius is 10, can I go like this equals 10?
Okay, yeah.
And then you can relate, you can find like this part by using Pythagoras.
Pythagoras. Okay, sounds good. Yeah.
So 10 squared plus x squared equal, like, let's say this is gonna be square root of this. Oh wait, no, sorry. Let me erase real quick.
Yeah. You can call this this part. You can call this the question mark.
Yeah, question mark squared, right?
Yeah.
And then to find this side of this entire thing, I guess, wouldn't it be 2 question marks squared, right?
No, it will be 2 question mark, not 2 question marks.
Oh, right, 2 question marks, sorry. And then question mark would be like, it would involve the x. So then you can relate this to this side, right?
Mm-hmm. Yeah.
And then would that be the function?
Yeah, very good. Very good. Okay. So you can do the same thing. Thank you, Leon. Okay. So it will be the same thing if you choose the other one. You could also say, okay, keep your picture there. Okay. Don't erase it. So for example, if we chose to be X up there instead, Okay, look at the blue one. Then I can do the same thing. I can say this part, okay, I'm gonna draw the other side triangle. Okay, look at the left triangle. Then I can say the bottom part is x over 2. And then the question mark will be the left side. This one is
Jason? Oh, sorry.
okay, and then you can still do the same thing to figure out the question mark. Yeah, Jesse, your question?
Wait, because you just drew the other radius. Then isn't the length in this case 10 squared, the square root of 10 squared plus 10 squared? Because it's a right angle.
Square root of 10 squared plus 10 squared?
Yeah.
Oh, you mean, okay, this is not right angle, you don't know.
What? But it looks like an envelope.
Huh?
It looks like an envelope.
Yeah, but envelope doesn't mean it's a
Oh
rectangle.
yeah, it doesn't mean it's a right.
You
Never
got to
mind.
keep in mind, this rectangle is changing.
Oh yeah.
Right? It's a variable, so it's constantly moving. Here, I just drew a random one. Right?
Oh, okay. So it just looks nice.
It looks like a rectangle, 90 degree, but it's not. Yeah.
Oh, okay. Okay.
Okay.
Thank you.
So since Leon already carried out the whole thing, right? I'm gonna choose the width to be x instead of length to be x. Okay. Another reason is if I choose the width to be x, the Leon's way, right? Then I don't have a fraction as one of the side, right? I don't need to do x over 2. Right? If I use the top one to be x, I need to cut in half. Right? So I will prefer the one that looks easier. All right. All right. So let me erase the notation here and then start again. Right. Oops. Okay. So I'm gonna choose this to be x. Right, and then draw the radius. Right, everywhere you draw should be 10. So then this part will be 100 minus x squared. Okay, if you understand the setup here, can you raise your hand? Jesse, do you get it? Jesse, is your mic working or not working again? Are you there, Jesse? Okay. Anyway, we'll move on, okay? If your mic is broken, let me know. All right, so here we are changing to
Wait, sorry. Did you say something?
yes, I
Sorry,
was
the audio cut out.
oh okay.
So that's why I didn't answer. I heard mic broken.
Yeah, I thought your mic is broken.
Oh no, sorry. The audio cut out, so I didn't know like what
So you
happened for like.
understand the picture now, right?
Yeah.
Yeah, okay, so let's
Thank
go
you.
ahead. 100 minus x squared, right? So that's how you set up something like this, right? You pretend it's a number, right? You pretend the width is a number, and then you think about how you can use it to find the other side. And we need to multiply by 2. Right? Any questions so far? Now we need to get the function, right? So area is length times width, so it'll be 2x 100 minus x squared. Okay, so of course this is different from the previous 2 questions. It's not polynomial, right? You cannot expand it out, right? So we're just gonna go ahead to step 3, get the critical values. Right, so please continue, right? Get a critical value and raise your hand, okay, if you find them. Anyone wants to check like or have question about how to prime this? Okay, Jesse, what's your critical values?
Oh, critical value. Sorry, I thought I was supposed to raise my hand when I'm done priming. Never mind. I don't have the critical values yet.
Okay.
Sorry.
Yep. Okay, I'm gonna show the step for prime. You can check if your first line is correct, okay? It takes a few steps to simplify before you get critical values. So for this one, you need to do product rule, okay? And also chain rule. So F prime G plus F G prime. Okay, let me know if any steps here is like you have question about. Okay, Jesse, what's your critical values?
Wait, I got 0. And okay, I have a question about the priming.
Yeah,
Because so I have like the same like A prime as you.
yeah.
Do I have to factor first, or does it not really matter?
Doesn't matter, right? But
Okay,
factor simplify will be easier to find critical values, right?
okay. And I also have 10, or like I guess you could do plus minus 10, right?
Well, this
Oh,
one, yeah,
it's
if
just 10, right? Because you can't have negative.
critical value should be plus minus 10,
Oh,
but
okay.
word problem you cannot have negative, right?
Yeah.
Anything
Yeah. Okay. No, that's all I got.
So just 3. Yeah.
Yeah.
Okay.
Except
Yep.
now I'm really doubting myself.
Jeffy,
But
how
that's
about you?
okay.
What's your critical values?
I got 0 plus minus 10 and 1, but I also not sure because the one I got from factoring. So
Okay.
Yeah.
Right. So if everyone is okay with the first line, let me simplify a little bit, right? Before you start factoring. So try to learn how to simplify too. That's important, right? 2 and 2 can cancel out, right? Reduce, right? So you can simplify into minus 2x
Wait, Jason, sorry. Would it be 2 minus 2x squared?
That's correct.
Okay, yeah, okay. Just want to make sure because that's what I had, but I was like really scared for a second.
Yeah,
Okay.
yeah, you're right.
Okay.
Thank you. Okay, if you guys got critical value, please raise your hand. Okay, Emily, what's your critical value?
0 and plus minus 10.
Okay, just those 3. Yeah.
Mm-hmm.
Okay, Carrie, how about you?
I also got 0 and plus minus 10.
Okay. All right, so let's check the factoring, okay? See if you guys got the same. We can take out the 2, right? They both have 100 minus x squared. So I'm gonna take that out. And then I'll take out the one that has the negative exponent to make the leftover look simpler, right? And then the leftover, what will be left inside after I take it out? Jeffy, what do you have inside?
I took out the positive half, and then I had left over 1 minus x.
Okay. Jesse, did you take out the one with negative half?
I took out negative because personally I don't really like negative exponents.
Yeah, me neither. Okay, so what's left inside?
I got left with just 100.
Just 100.
Because when you take out the other one, it's just 100 minus x squared, and then you're left with minus x squared.
Minus x squared.
Oh shoot, that's 100 minus 2x squared. I'm so sorry.
Okay, is there any question about this step, the leftover inside? It doesn't matter which one you take out, right? You should end up with the same answer, okay? Just that if you take out the one with the negative, it will make your work easier on the inside, okay?
Sir?
Yeah.
Can I add something?
Yeah, what do you add?
Plus minus 5 root 2.
By root 2. Like
Yeah,
that?
because I realized I did the math wrong on one of them. So
Okay.
I need to add one more.
Okay.
Thank you.
Anyone else finish the critical value? Can you raise your hand? Okay, so over here, if we simplify this, right, the numerator will have a 2 and 100 minus 2x squared. Right, and then denominator, you would have root 100 minus x squared. Okay, so the hardest part, right, is actually how to get here. It's not really hardest because we've been practicing this in the when we learn product rule. Okay, so just make sure you know how to do the algebra correctly. Okay, so critical value, you need to get it from the top, right, equal to 0, and then the denominator is when f prime is undefined, right? So from the denominator, you will have plus minus 10. And then from the numerator, right, 100 minus 2x squared, if you make it equal to 0, x will be plus minus root 50, right? And then that can simplify into 5 root 2. So that's where Jesse got the plus minus 5 root 2 from. Right, so you should have a total of, where's the 0 you guys got? You all have 0, right? Where did you get zeros?
I don't know.
Yeah.
I honestly don't know.
Yeah, okay. How did you guys get 0?
I got the 0 because I didn't put it to the bottom or something. I don't know. I can't remember.
Yeah, okay. Well, take a look at the step. Is there
Yeah,
any
I don't
step
I don't even know where I got 0 from. Like,
yeah,
nowhere in my
you
work
will
does
get
it say 0.
Yeah, you will get 0 if there's an x by itself, right? Then that's how you can get a 0. So double check your work, triple check, right? And try to compare my steps here. So your critical values will be 4 of them. Okay, so you have plus minus 10 from the denominator and plus minus 5 root 2. Now, before we before we do the testing, right? Because 4 critical value is a lot, right? So let's look at the picture. Remember, the x represent the height. You could call it the height,
Yeah.
right, of the rectangle, right? And the tallest that x can get, how tall can it go?
It has to be less than 10 because your hypotenuse is already 10.
Because it has to stay within the semicircle, right? So I think the skinniest rectangle looks something like this, right? This one will be almost 10, right? Of course, has to touch the end, right? So you should also keep in mind you need to write out the domain on the side, right? So that way you don't use all the critical values. Okay. So
Wait, Jason?
So here, let's write it. Yeah.
Wait, we also can't have negative, right? Because you can't have like a negative.
That's right. Okay, so x has to be less than 10, bigger than 0. Well, you could put equal, right? Equal means there's no area. So if they are looking for a minimum area, then that will also be important. Okay, so critical value here will also include the, so that's where you can put the 0 into your critical value. Okay, critical value includes the endpoint of the domain. Okay, so we're gonna get rid of the negative. So total you have 3 critical values. Okay, remember endpoints are also critical value, they are important. So finally, right, when we do testing, we just put 0.
Wait, sir, I thought we got rid of 0.
Yeah, we got rid of 0 because we don't see 0 anywhere in
Oh,
the,
but endpoint, right?
the 0 is coming from the endpoint of the domain.
Oh, okay.
Okay,
Thank
so
you.
you guys got the 0, right? Very lucky, huh? Okay, so we have phi root 2 in here, right? Phi root 2. So we just need to test, right? Test now. When we do the testing, right? We don't need to test the denominator. Why is that? How come we don't need to test the denominator? Carrie? Do you understand my question?
You cut out for me. Can you repeat it, please?
Okay, yeah. So when we start to test the points, how come we don't need to test the denominator?
It has to stay positive, right?
Yeah. Okay, so the denominator has a square root which will stay positive all the time. So it doesn't matter what you throw in, right? It's not gonna affect the overall positive or negative. So we just need to test the numerator, right? So here, let's say we pick 1, right? And we don't need to test the negative side. We don't need to test the bigger than 10. So that's why I cross it out. So if I test 1 and throw it in, it will be positive, right? And then if I try, let's say try 9, right? It will be negative, right? Something close to 10. So that makes it increase, decrease, and that confirms it's a local max. All right, so we can write out our answer. Find the area. Remember, this one we're not finding the dimension. So the area, how do we get the area then? Joan?
We have the function that we got.
Yeah, and then what do we do?
So you just plug it in.
Plug what in?
The 5 root 2.
Yes, very good. Yeah. Okay, so please everybody plug it in, and then once you get the area, raise your hand. Okay. So you can say the max area is Okay, Lex, what's the area? Lex, are you there? What did you get for the area?
Isn't it like 50?
Say that again.
50? I think.
50. Area is 50. How about you, Leon?
Different answer. I checked.
Yeah, what's your answer?
I got above 100.
Above 100. So what exactly is it?
136.33.
136.33. And then you have 50. Okay.
Wait, I did not get that.
Jesse, what do you have?
I just got 100.
100.
Yeah.
Joan?
I also got 100, but now I'm confused.
Okay. Okay, come on. The last step is just plug it in, right? You guys can do it. Double check, please. Jeffy, how about you?
I got 136.33, but now I'm not sure if it's right.
Oh, interesting. Okay. All right. Anyone else got 50? Emily, what do you have?
Give me a second,
Okay.
because I have 100, I think.
Okay. Anyone wants to change answer? Or should I show the steps? You could even just plug everything into calculator, right? So I don't think you will have trouble with this. Double check, okay? If you want to change answer, let me know. Nicole, do you have an answer?
I have 100, but I'm not sure.
Okay, you have 100. More people have 100 so far.
100.
You got 100 now? How about the 136.33 people? Have you found the new answer? Or should I show the work?
Yeah, I think I'm lost.
Okay, then let's go over the step, okay? I'm gonna sub it in on the top then, okay? So by hand, right? Without a calculator. So 2 times x. So Leon, what did you plug in for x?
5√2.
Yeah, 5 root
Wait,
2.
Jason,
Yeah, Jeffy?
I forgot to square on the inside, so I forgot.
Oh, same.
Yeah, it's
Oh,
100.
okay. It's all right. Yeah, try again, okay? So hopefully you guys got the 100, okay? So 100 cm squared. Okay, so that should be our maximum area. So if the question asks for dimension, then you find the length and width, okay? So you just take the x, plug into your last statement. All right, so ready for the next one? We have a 3D for the next one. Also try to inscribe something in there. Similar idea, right? So think about how we did the last statement. So I'll let you try this, okay?
Wait, 40, right?
Yep, 40.
Okay.
So here we want to place what inside what? Jeffy?
We're putting a cone inside of a sphere.
Okay, and the sphere has a radius of 24 cm. Find the dimension. So this time we want to get dimension of the cone, right? Of the cone. So you need to know something about the cone as well, right? To maximize the volume. volume of the cone, right? Because sphere is fixed, right? You want to place a cone inside a sphere. All right, so start with a picture, okay? If you got a picture, can you raise your hand? Okay, Carrie, are you able to draw on the screen?
Yeah, I'll do it.
Okay.
Wait, Jason, I'm a little confused.
Yeah.
For like, for height of the cone,
Yeah.
it can it reach the max or no?
Yeah, because you want to make the cone as big as possible, right?
Yeah.
So it has to reach the ball.
Yeah, no, but I was thinking like, cause like, you know how the top of the cone is flat, right?
Top of the cone is depending on which way you call the top, right?
Or like, the circle part is flat, right?
Okay, yeah.
Then, so it can't really touch the highest part of the circle, right?
Can really touch the, yeah. But you just try to make it as wide as tall as possible.
Oh, okay, I see.
Yeah, you can see Carrie's picture now,
Yeah.
right? Yeah, so her cone is having the base, the circle at the bottom, right? Of course, you can flip it upside down, okay?
Mm-hmm.
Yeah, it doesn't matter, right? So let's just use her picture for now, right?
Okay.
Okay, so I'm gonna redraw that picture. Thank you, Carrie. Can you help me erase, please? Very good. Right, so here we have a circle and we place a cone and then make it as big as possible so all the corners, right, edges has to touch the circle, right, sphere. And then the sphere is 3D, right? So it has a radius coming out from the center, right? Hopefully I don't make this picture too messy, right? Yeah, so that's a picture. So you guys try. Radius is 24, so I'm gonna just say diameter then, right? Diameter from edge to edge is 48 then, right? Same idea. So let and function. So we need something to be x. Of course, the thing you want to optimize is the volume, right? Volume, let's call that V. So what are the other two dimensions? The name, what's the name?
The height and the width,
Height.
or like length. I mean, whatever floats your boat.
Height of the cone, right?
Yeah.
What else?
Or like how wide it is, right? Because
How
we know
wide would you call that? The what?
width, right?
It's a circle, so you could just say the diameter,
Oh,
right? Or radius, right? Radius of the cone.
okay.
Okay. Make sure you don't confuse the radius with the sphere, right? We are interested in the radius of cone. Okay. Height of the cone. Let me be clear. And volume is volume of the cone. Only the cone is changing, right? So we have radius of the cone. And then one of them needs to be x. So what do you think?
Radius is x?
You want radius to be x? Okay.
Yeah.
Let's put that there. Radius is x. Right, so now you need to think about, if I know radius is x, how can we get the height? This is height of the cone. And if you are not sure what to do, right? Think of a number. Think of a number for x. And then imagine if you know the radius of the cone, how can we find the height of the cone? Right? So you can say, pretend x is, because radius sphere is 24, right? So let's say if this one is 20, right? How can we get the height? Right? Having a number will be easier to think.
Can we use Pythagorean? Wait, never mind.
Anyone wants to try? If I know x is 20, is there a way to find the height?
Wait, we have like volume of cone formula, right? Can we use that?
But do you know the volume? The volume of the cone is changing though.
Oh,
It's not fixed. The only thing that's constant is 24.
okay. Do we do Pythagorean theorem?
How?
Like you can draw a right triangle, right?
Where?
Can I try?
Yeah, please.
Okay, thank you. Like this, right?
Okay, and then what?
Because if you know, like, oh wait, never mind. Because you don't know anything else, right?
Well, you know the diameter is 48. That's the only thing you know.
Yeah, but then I
Wait,
don't
I have a
know.
question.
Oh, sorry.
No, it's fine.
Emily?
But is it possible that you like ping pong it? Like, the radius is like that, right? And you can just stick it out to the right, and then you just make 2 lines.
Can you draw it? I'm not sure what you mean 2 lines. Let me
Like if you did that,
yeah,
and then you did that, and then you did that, and then these 2 would be right angles, right?
which one
In
will
theory, like here.
yeah, those 2 will be right angle, yeah.
And then
But then where are the green lines meet? How do you know where they meet?
because
They meet
sorry, it's a really bad drawing, but if that was the radius and then it went all the way up to the tip, but sorry, I'm on my phone, so.
Okay, yeah. So, okay, can you erase it? I'll redraw it. Okay.
Yeah, Jason, I also kind of had a guess on how to do it, but I'm not really sure. But it's kind of similar to Emily's.
Okay, I'm gonna draw Emily's out first. Okay, see if that's what she meant. So you mean connect to the edge of the sphere like that?
Yeah.
Okay, and then connect like this.
Mm-hmm.
Yeah, and then what? What do you want to put on the picture now?
I don't know, but like, because you know the radius, and oh wait, we don't know the height.
Yeah,
Never mind.
You think about our goal, right? Our goal is to get the height using the 20, right? The 20 is something we made up, right? The x. Using the x, I want to figure out the height. Anyone wants to take over or add something to this picture or change?
I have. Oh, never mind.
Oh, just kidding.
Huh? John, you want to say
Or
something?
wait, does Leon want to do his
You
first?
can go first.
Okay.
Okay.
Wait, can I draw on the thing? Mine is like slightly different, but it's kind
Let
of the
me
same.
erase it first. Then. Okay.
Yeah.
Yeah.
I don't know. This seems really complicated though, but it was the first thing I thought of, so I don't know.
Okay, go ahead. It could work, right?
Okay, let me just do my annotate thing. So wait, what I had the idea was like using the same idea because you know that this is the radius. So
Mhm.
like that's 24. And then
24.
since that is like a right triangle here, then you can use Pythagoras to find the little height to the middle of the sphere.
In this part,
Yeah.
the
And
little
then
L8.
yeah.
Okay.
And then since like the rest of it is just from the middle of the sphere to the outer edge, it's going to be 24 because that's the radius.
Which part is the 24?
This, oh, that's not a straight line, but pretend that goes to the top of the cone.
Okay. Okay. So that part is 24.
Yeah,
Yeah. So what's the height?
just 24 plus the little height you calculated.
Okay. Does that make sense to everybody? So
Yeah.
far, feels nice. Yeah. Jesse. Yeah.
Yeah, it's too genius for me, but I'm like I kind of understand it.
How about Leon? You were trying to say something?
Never mind.
No? What do you mean? Never mind? Did you have the same idea? You got something different?
I was thinking I got something different, but I realized it's wrong, so it doesn't matter.
Okay. Okay. All right. So this one is like kind of like an application of another way to apply like Leon did last time, right? Whoops. Okay. Anyway, over here.
Wait,
Hey,
I'll clear it, sorry.
Jason,
Yeah.
is this supposed to be like super hard?
No, no, it's not. This is something that's similar to what we did over here,
Oh,
right? We apply
yeah.
the Pythagoras again, right? Just like Leon said before, and then using the Pythagoras, right? Try to set up the missing side. Except this time, you just need to add the 24, right, to the very top to be the whole height. Okay. Okay, so that's our, let me shade it in, that triangle. Okay, that's a good discussion, okay? Everybody gets to think about it and get some input. So let's put in, so we are going to erase the 20 now, right? 20 is just to help us think, right? So if radius is the x, let's go back. Radius is the x. Okay, then the wrong place. Radius of the cone is the x. So the height of the cone will be 24 added with the little height. And what's the expression for the little height?
Is it square root of 24 squared minus x squared?
Mm-hmm. Minus x squared. Any question about the setup so far? So I guess the hardest part is not getting the function, right? Hardest part I think is getting the last statement. Otherwise you can proceed to step 2. Right, 24 squared, let's put that in numbers, okay? 24 squared is 576. Okay, so let's put that down. Any questions?
Wait, in this case, because they're asking about the dimensions of the cone for volume,
Yeah.
then we need to put this into the volume formula for the cone.
Yeah. That's right.
Okay.
That's our step 2 now. Okay, so step 2 is to get the function that connects all of them, right? So the function is V equal, anybody remember the volume of cone?
It was something over 3, right? Like radius squared or radius cube or something. Oh no, radius squared pi times height or something.
Pi
over 3.
r squared height.
Yeah, over 3 or
Over
something.
3, yeah, times
Okay.
1. Okay, so we're gonna plug it in. 1/3 pi, radius is x, height is 24 plus 576 minus x squared. Okay, you can leave it as it is, right? Or if you want, you can multiply in, doesn't matter, right? And then you can start to do the prime. I'm gonna just leave it like this, okay? Because you got the product rule, right? So please go ahead, find the critical values. And raise your hand if you found the critical values. So be careful when you do the prime and simplifying. The 1/3 pi is a constant, right? So you could leave it at the very front, or you could treat it as a part of the together with the x squared. Okay, doesn't matter. I'm gonna leave it at the very front. Yeah, this is my first line. I left the 1/3 pi at the very front, and then just apply the product rule to x squared and the bracket. Let me know if any step you don't understand. Okay, and then going to simplify this now. Okay. Jesse, you have critical values?
I hope they're right.
Yeah.
I got wait, I kind of factored it different from you.
Yeah, and then depending on how you approach it, right?
Yeah, one
Did
of
you-
them sorry?
Okay, go ahead. Go ahead.
Oh, one of them I got 0. The other one I got where did it go? Plus minus 24. Or I guess in this case it's only positive 24.
Yep.
Right?
Yep.
That's it.
That's it.
Yeah. Except I kind of factored it kind of messy.
If it's like plus minus 24, then that means your radius is same as the.
Oh yeah, that doesn't make sense.
It could be, but I don't think it will be the same.
Wait, can I try factoring it one more time, please?
Yeah, yeah.
Okay, thank you.
Okay. Yeah, it's very easy to make a mistake, okay, when you are priming. Emily, what's your critical value?
Wait, give me a second. I just realized I forgot something.
Okay. I'm double checking too, right?
Wait, sir?
Yeah.
I got 0.
Mm-hmm.
Wait, do we still include 0? 'Cause 0 is an endpoint, right? So we still have to include it.
Yeah, yeah, include
And
that.
then plus minus 8 root 2.
Mm-hmm.
Or yeah, square root of 3. Yeah, 8 root 2.
That's it?
Yeah.
Okay.
Now I'm scared.
So confusing with all the brackets.
Jason,
Yeah.
I got it plus minus 20.
plus minus 20.
Yeah.
Anything else? That's it?
I also have like the 0.
And 0, okay. That's all? It looks too complicated to.
Could we just keep it how you did like the 48x one?
Yeah.
Like the yeah. Wait, I don't know. This is very confusing, but
Yeah, this is. I'm just double checking if there's any mistake here.
okay.
Carrie, what do you have for critical values?
I got 0 plus minus 20, and I somehow got plus minus 24.
Okay, plus minus 24. Okay, let's have a break first. Okay, after the break, let me double check the work here and then calculate the critical value. Okay, and after the break, we'll go over it. All right, so 15 minutes. Okay.
Wait, Jason.
Yeah.
I just looked at my work again, and like I thought I knew what I was doing, but I obviously don't know what I'm doing again. So you might want to erase my answer.
Okay.
Yeah.
Yeah. Okay. So you guys can keep on trying. Okay.
Okay.
And after the break, we'll check the critical values.
Okay. Thank you.
Okay. Yeah.
Thanks, Jason.
You're welcome. See you soon.
Thank you. Bye.
Bye bye.